Okay. A very good evening and a very good day to everyone. My name is Nanda Kumar, son of Mohan. This is the presentation for our group project, which is for design for manufacturing and assembly. So my name is Nanda Kumar, son of Morgan, and my meeting number is 181402969. And I would like to introduce my team members, which is number one, Tanaseelan, son of Padmanathan, and the second one is Anusha, daughter of Magendran. Okay, next. So this is the project title and image for our product, our project, which is self-watering system. Okay, next. Now I would like to giving some introduction for our project, which is the self-watering system. Plants always need water, so we need to understand their situation and the specific time when they need it. An automatic watering system is a completed time-based water supply for crop, which is minimal human intervention to just supervision. It's mean as a human we no need to water the plant, but we can setting it to automatic watering system, which it can be water to the plant automatically. And the third one is there are various benefits for automation, where the major one is reducing labor cost in exchange as for an efficient water supply system. As I mentioned before, this it is for reducing labor cost and also reduce their time. Okay. Existing which is the self watering system, usually fully mechanical system without any electrical help. And the second one is the check valve is to control the water flow. When the water level is low, the check valve moving down to allow the water flow to the plant, and at the same time to water dripper storage. And the another point is water is allowed to flow through the check valve. And the last one is the wall move up and down inside the wall depending on the water flow and seals of the cap. It means the self watering system is held between each other to make sure the water is going to the flower on the time. Okay, next. This is the bill of material, which is for our project, the component name, quantity, material, and also manufacturing process. All of our project is based on the injection molding manufacturing. And the material for our project is number one is PVC rigid for cap. Second one is PVC rigid with chrome plated for the component check valve ball. And the third one is PVC rigid for elbow connector, PVC rigid, and other is all following the PVC rigid, which is for hydraulic check valves, straight connector, water dripper storage, and also Y connector. This is the bill of material for our project with the suitable manufacturing process. Okay, next slide. I would like to pass to my team member, which is Anusha.
Hi, now I would like to explain about the functionality of the component. The first part is cap. This cap is used to tighten at the bottom of hydraulic check valve body to hold the water flow and check valve ball. The second one is check valve ball. It is a moving part to block the incoming water flow. Once the water level is low, by the water dripper storage, the check valve will be moving down to allow the water to flow to the plants. The third one is elbow connector. This elbow connector is Y-shaped. It changes the flow of water to the water dripper storage. Fourth one is hydraulic check valve body. This is the base part where all other parts are connected or screwed tight within. The next one is straight connector. The straight connector part are screw connected to the hydraulic check valve body and water dripper storage. This part acts as a water flow connector between hydraulic check valve and water dripper storage. The next one is water dripper storage. This is the part where screw tied to the straight connector. This part acts as a water flow controller for the water dripper storage to drip at the lower position of the check valve to allow for the water flow. The final one is Y connector. This part allow the water to flow to the plant and all other diverted channels. It stores water at the water dripper storage at the straight water channel. Next, Nanda will proceed.
Okay, thank you to my teammate Anusha. Now I would like to explain about the drawing for each existing component. Now I would like to explain about the existing component only. The improvement component will be conducted by my team member Tanaseelan. So this is the drawing for part cap. Next slide. Next. Okay, this is the drawing for check ball. Next, it is for the elbow connector. Okay, this is the hydraulic check valve. This is the image and also the drawing for hydraulic check valve. Okay, this is the thread connector. This is the water dripper storage, which is used to water will drip and also store in the automatic watering plant system. Okay, next. So this is the Y connector for our product. Next. Okay, this is the assembly part for our component with trimetric view with scale 1.1 assembly self-watering system. Next. Okay, this is the exploded view for our project, which is for self-watering system for exploded view and assembly uh, and for the assembly system. Okay, next slide. Okay, this is the DFA table analysis for our project, which is for the existing component. As I mentioned before this, there are 7 components, which is hydraulic check valve, ball, elbow connector, cap, straight connector, water dripper storage, and also Y connector. All of the quantity is only one. So this is the table analysis for DFA with the manual handling code, manually handling time, manual insertion code, and also time, the total operation time, also the assembly cost. So based on the total quantity for our quantity is 7, and the minimum part cost count is followed by 3, and the manual handling time is followed by 10.1 second, and the manual time insertion time is 17. Total operation time is 27.1, and the last one is assembly cost, which is only 20.32 cost cent. Okay, this is the calculation part for our project, which is for DEC, design efficiency calculation, with the percentage of 33.2. And the last one is for the assembly cost, which is 20.32 cent, as I mentioned before, and also 20 cent only. It is the assembly time for followed by labor day. Okay. Next slide, I would like to pass to Mr. Tanaseelan for the recommendation for improvement for our project.
Okay, today I will talk about a recommendation for improvement. Next slide. Next slide. So this the bill of material, which are 3 components only, which contain cap, check valve board, and hydraulic check valve body. Next slide. So this is the drawing for the improved component. The first one is hydraulic check valve body. So this for the cap. This is for the assembled self-watering system. Next slide. So these are the exploder view. This is the exploder view, which contain the check valve board, cap, and the hydraulic check valve body. This is our DFA table analysis, which we reduce the manual handling time to the 4.47 second, and for the insertion time to 11 second, and the total operation time to the 15.47 second. Thus, the assembly costs are reduced to 11.6 cents. So the design efficiency is increased to the 58.2%, and the assembly costs are reduced to the 10 cent. Next slide.
Okay, now I would like to explain the comparison table. In our existing part, the total part has been reduced. In our improved design, it is 3. The total operation time it has become 15.47 seconds in our improved design. The third one is assembly cost, which is 7 ringgit 60 cents, and the design efficiency has increased to 58.2%. In conclusion, the number of components and the method of installation are important factors influencing the efficiency of product design. In this investigation, the total number of components of the improved design was reduced from 7 to 3 components by using Dfma analysis method. The operation time also has reduced from 27.1 second to 15.47 seconds. Uh, the percentage is 23.75 percentage. The reduction in installation time is due to the removal of merging of certain components based on the results of Dfma analysis. The reduction of these components will ultimately improve the ecology of the product. Thank you.
Okay, thank you very much for listening. That's all from our team, and also have a happy weekend. Thank you very much.